To say that performance is important is an understatement. After all, Redis was built for developers requiring sub-millisecond data access. Of course, performance is also a wide-ranging topic, and in this unit we're going to stick to performance considerations for the application developer. These considerations can be divided into three main categories. The first concerns network latency, the second concerns the time complexity of Redis commands, and the last relates to atomicity and blocking. We've already discussed latency, but let's review the main points. First, you should use pipelining whenever you need to run more than one Redis command and don't need an intermediate response to those commands. Pipelining cuts down on the number of round trips your client makes to the Redis server. It also results in less context switching on the server side and fewer syscalls. This is especially important when you're potentially making tens of thousands of calls to the Redis server. For example, in this findAll method, we first fetch a set of keys, and then for each key, we call hgetAll. This is the scenario you need to watch out for. In general, when running commands in a loop, you should strongly consider wrapping the loop in a pipeline, like so. Now let's talk about the time complexity of Redis commands. In general, it's important to be aware of the time complexity of the commands you're running. You can find the time complexity for every Redis command on the redis.io website. Constant time commands are the most efficient, and happily quite a few Redis commands fall into the O of 1 complexity bucket. These include get, set, hget, hset, lpush, lpop, sadd, srem, and many others. You generally don't need to worry about the performance of these commands. Logarithmic time commands are also very efficient and generally should not cause concern. You'll see these commands described as O log n. We can see why these commands are efficient with a little math. Log base 2 of 10,000 is only about 13, and log base 2 of a million is only about 20. Many of the sorted set commands, such as zadd and zrank, are O log n. So running zadd on a sorted set with a million elements has a time complexity of O of 20. It's the linear time commands, the commands marked O of n, that you need to be careful with. But even here, it all depends on the value of n. For example, let's take a look at the lrange example. You may recall this code from earlier in the course. Here, we're calling lrange to return all the elements of a list. If the list contains 50 elements, then this command has time complexity of O of 50, and Redis can execute such a command in a matter of microseconds. Yes, I said micro. But if the list contains a million elements, then we're at O of a million, which is a completely different story. Running O of n commands where n is large is a problem for two reasons. First, these commands can take a relatively long time to complete. This is because they use a lot of CPU and they tend to return a lot of data, which takes time to buffer. Second, because Redis is mostly single-threaded, no other commands will be executed while these long-running commands are running. All other client commands will be queued up until the current command is done running. So to take an example, on my development laptop, running an lrange to retrieve all the elements in a 4 million element list takes the Redis server about 300 milliseconds, or close to a third of a second. So if we have 1,000 clients all issuing commands against the Redis server, and one client issues a command that takes 300 milliseconds for the server to process, then those 1,000 client commands will all queue up behind that long-running command, and they'll all have to wait for at least 300 milliseconds before each of them is served. There are a few O of n commands that you should almost never run in production. The most notorious of these is the keys command, which returns all the keys on a server matching a given pattern. As an example, running keys star on a key space of 4 million keys on my development laptop occupies the server for 4 seconds, and it's common for Redis servers to host hundreds of millions of keys. So we recommend never running the keys command on a production server. And if you build extremely large lists or hashes with thousands of elements, then you should probably also avoid lrange and hgetAll as well. It's a good practice to disable such commands altogether. See the links on this page for documentation on disabling commands. Okay, to round out this chapter, let's review atomicity and blocking, specifically as they relate to transactions and Lua scripts. In Redis, transactions and Lua scripts both run atomically and block, which means that while they're running, no other commands can run. So you always need to keep this in mind when using these features. When running a transaction or Lua script, consider the time complexity of the commands you plan to run, and understand the cost of running thousands of commands within a transaction or Lua script. If you don't need transactional semantics, use a pipeline, which doesn't block for the duration of its run. Redis is a high-performance data store that keeps all of its data in memory, but you still have a responsibility to understand the cost of network round trips, the time complexity of the commands you're running, and the cardinality of your data structures. You'll get the most out of Redis by paying attention to these considerations as you design your data access strategies.